I just want to show you, I had a problem with the link for today's class. If it is broken, you can find the slides using the full address here. I sent that on Slack, and it's the same thing. You don't have to install now, but because we won't be using in the tutorial, but there are two other packages that I'm showing in today's class, patchwork and ggrids. You'll need it to run the code that is inside the slides. And we will run today not an R code, but an R markdown code with a graphic, and I will show you how to save it and some other things. So today we'll talk about graphics. It's a super fun topic, but also annoying because sometimes we get stuck doing graphics. I'll talk about graphics good practices, a bit of graphics grammar, because this is super related to the way that ggplot is built. And I will give a lot of examples with ggplot too. There are tons and tons of examples today, but we will be, in the tutorial, generating one graphic, okay? It's a lot of information. I'm showing you a few options. It's not an exhaustive list of options, but it is a start, okay? There are lots of references for graphics, and I will show you that during the class. So data visualization has many don'ts. So the main important thing when we are visualizing data is the data itself. So it should be clear. We should always avoid 3D plots. There's always a better way to show that same information. Here, for instance, I can collapse one of the axes here to a stacked bar plot. So I have here an X variable, 3 treatments, and Y variable, the values here. And each treatment, I have 3 classes, high, medium, and low. And here, I was separating 3 axes. Here, this is a much more concise information. We should never do a pie chart, but mostly never a 3D pie chart. This is much better already, but there are better ways, always a better way to show the information that we need in a pie chart. A pie chart can be used if we have like 2 classes, 3 at the most. But if we have a lot of classes, this is very difficult to quantify the amount of these. Sometimes people do the donut plot with a hole inside. This is better for visualization, but still, I really think that there are better ways of visualizing these types of information. Here is the percentage of something across countries, different countries. And this is easy to compare between countries, but this is much better because now we know the direction of it, and we can guide the information that we want the reader to focus on. And bar plots, they are not always very informative. Here, usually in a bar plot, like I want to say that A has 4, B has 8, C has a little bit more than 14, and so on. This is a lot of ink to show just 5 information. It's more important, it is better if we can add for every mean value. If we have the information of the variation, we should add that on a graphic. We can do that with a bar plot. But maybe we don't even need a bar plot for that. In this case, I have the mean value and the variation. This can be plotted this way. And sometimes, if we have not that much information, we should think, do we need a graphic? Like, I could pass the same information using a table, or maybe writing inside the text. So first thing is, do we need a graphic? And second thing, how we build that graphic. One important thing here is there are a lot of tricks, and we see that in elections, because when the media shows, one loves to change those things. But this is Fox News, and they are changing the increase of cases per day. And note here that those grids are equal, but the numbers here are not. So the scale is completely messed up, and this affects directly how we are seeing the data. Here there's a really nice blog post about this, and they built the same graphic using ggplot and now fixing the axis here. They also create the same graphic with this messy scale. It's a lot of lines just to mess with the scale. So this is even easier to do, and this is how we should see the variation of this time scale graphic. So some basic tips in general: only make plots when you really need to. Don't spend more ink and colors than you need to. Imagine, well, that's real, like you pay for publishing things with colors, so do we need colors? Do we need a huge bar? This is something that we should ask ourselves. Do not fool your reader. It's always advisable to show the error measures, if it is the case. And in R, like, we can plot using RBase. I did that for many years, and in some occasions I sometimes prefer using RBase. But independent on what tool you are using, there are a few good tips here. Like, never in RBase, the default for the y-axis is the number to be horizontal. So that is harder to read. So always make our y-axis labels horizontal and visible. Avoid colored backgrounds. We'll see that ggplot by default has a gray background. I will never understand why they did it, but we can change that. For scatter plots, we should always use dots unless we want to show like different categories in the same graphic, then we can change. But dots are usually the go option here. It's easier to read, and it avoids tricky interpretations. We should always add names to XLab and YLab, and save to PNG and PDF formats. For figures, TIFF is a good format too, but PNG, it's much better than JPG, and those are basically the best formats to save a graphic. So ggplot is based on the idea of the grammar of graphics. And it's based on this book. This is from 1999. I saw once one of the co-authors of ggplot in a talk, and he was saying, oh, this is a super recent book, and then he realized that it's from 99. And oh my God, I'm old. And I had the same reaction, like, oh, it's not that old, but whatever. It is the foundation for, so this book has a theoretical deconstruction for data graphics. So it's the foundation, like, we don't need to read this book to use ggplot, but ggplot was based on this theory. And it's the foundation for software, not only ggplot. VigaLite is an application for doing graphics as well. It's also based on the same grammar. But it defines how to design a system that will allow us to build nice graphics. And the name ggplot, GG, stands for Grammar of Graphics. So it was completely based on this idea, adapted because not everything that is there is on ggplot. There's an open book available about ggplot. There are tons of other references. There's the R Graphics cookbook, because ggplot is still more conceptual. It does not provide all the options, like a menu for graphics and all the options for that. It gives you the idea of how to deal with ggplot and how to read and write in ggplot language. And it has a lot of explanation about the underlying theory. And the idea is to empower the reader to be able to do a plot whenever the way we want. And the idea behind the grammar of graphics is that usually in RBase, for instance, if you want a bar plot, there's a bar plot function. If you want a histogram, there's a histogram function. A density, we should use a plot density function, a box plot function, and so on. So for each graphic, we have one function or one way of doing it. The idea of the grammar is to decompose the graphics into common constituents, which are a theme, the coordinates, the facets, if we have like different panels, the geometries, the scales, statistics, mapping, and data. If you already used ggplot, this is something that, like, mapping is an argument in a function. Data is an argument. All the functions in ggplot to actually plot start with geom. So it actually translates this grammar to R. And the basic thing for plotting, well, we need a data. And ggplot and this idea of grammar of graphics will require data in a tidy format, variables in columns, each observation in a different row. There was not, like, tidy data was not a thing when the grammar of graphics were published, but this idea is solid and it exists in the book. So about ggplot, I will show you a lot of different plot options. We will not read, but we are basically tabulating data directly in R. This is a tooth growth data set that has data on the effect of vitamin C on tooth growth in Guinea pigs. And we have here two variables, the tooth length and the dose. So we have different measures of the teeth length for each dose, okay? We'll make a bar plot with that. And the way that ggplot works, here we will start using the plus. When we are in RBase, we don't need to use the plus to add. We make a graphic and we want to add a line. We don't need the plus there. But in ggplot, we need, because we are adding layers to the graphics. And this is, again, related to the idea of the grammar of graphics. And we need to specify the data, obviously. Mapping, in mapping, we specify the aesthetics of it. And we specify here the X and Y axis. Note that in R, when we need to select like a column, we would use quotation marks. But here, we don't have an object called dose. We have a dose column in my data, in my GF object. And because of that, and because we are using those inside the aesthetics, we can use that, okay? And I want to plot something. To plot something, it's always ggplot function. It will be always the same function. What I will do with the data comes next. I want to do a bar plot, so I will use geom bar with a stat here called identity. I will get this graphic. In my x-axis, I have the 3 different doses. In my y-axis, the tooth length of the Caenia peaks. This is the same bar plot, okay? We can, here, I'm specifying data and the mapping inside the ggplot function. I can either do that or ggplot empty and specify data and mapping here. Or I can specify only data in ggplot function and geom bar only the mapping. There are different examples of that during this code. But with this command, we'll have the exact same output. And notice that I'm here assigning to an object. If I don't assign, I will see my graphic. I'm assigning to an object, and when I do that, I can add other things to that. So in my bar 1, I want to flip the coordinates of my bar plot. So I simply call my first plot plus a function that will flip the coordinates here. We can change the color of the bars, basically the way we want. There are different ways of specifying colors inside R. We can use the name. There are a restrict number of colors when we are using this notation. We can use the hexadecimal code for each color. Each color in the computer have a code. We can either use the hexadecimal code or the RGB code. And with that, we can specify basically any color that exists. And I'm doing this by specifying in my geom bar function how I want to fill it. So I want to fill with the color red. And then I get this, okay? I can use the hexadecimal code. This is our favorite red color, and it matches with the slides now. And this is another way of specifying a color. And here we are seeing this gray background. And the way we can change that is changing the theme, the default theme on ggplot. We'll do that by adding a theme. So the way I do that is adding a theme classic. This is like easy, and this is a safe choice for plotting. We have the labs, Y labs vertical. We have the tick marks outside the graphics. This is nice too. We have a L box type here. In our base, the default of the box is a closed box, a squared closed box. This is like a safe choice. But this is still super small. We cannot like read really well these numbers and the axis. And we can change those things, obviously. And what I'm doing here, like I can change the theme parameters using the theme function. So I want to change the size of the axis title in x-axis. The same thing for the y-axis. I also want to change the size of the axis text, which are those numbers here. And I will do that using a function called element text. This has a lot of different arguments, but here I'm changing only the size. And because I want the x the title and the text to have the same value in both x and y axis, I'm defining those parameters earlier so I don't have to repeat 18, 18, 16, 16. That's why I'm doing this. So after doing this, and I'm creating, so I want my theme to be the classic theme with those modifications. And I'm calling this my theme, okay? This is my precious theme, and I will add that in my graphics here. And now we can like read a little bit better. And here I'm also specifying, I'm changing, like by default, the name of the axis will be the name of the columns. So it's those and length. And here I'm defining new labels for x and y axis. I can change the color. I'm doing this by hand. When I do this by hand, okay, let me get back a bit. I'm specifying here in order to change manually or their color palettes that exist already inside ggplot. But I'm here defining a color palette by hand. And when I'm doing this, I will change that using the function scale fill manual. But we will do that. If I do only this, this will not change the value. I need to tell that I want to fill which variable I will be coloring. And I will do that in the mapping argument in the aesthetic, inside the aesthetic function. So I will use here those column on x-axis, the length column on y-axis, and I will color based on the those column. So I'm specifying here that the those column will be colored and how I want to color this. If I don't use this line here, it would use the default colors here. I'm just changing it. But a thing that we need to ask is, do we need like 3 different colors? I mean, it is the same information. This could be easily gray bar plot. We don't need colors. If we are publishing this in a paper, we can save a little bit of money if we don't use the colors here. We can do bar plot with subcategories. It is the same as the first slide. And now here, I again have the same data, but now I have one additional information that the different doses for each treatment, each dose, we had 2 different types of delivering the vitamin C to the subjects. And we have now that information. So it's the sup column here. It will tell us the delivery method. So now we have a table with sup, dose, and length. And the key to... Good. No, I think it's better to ventilate the room. I think it's okay. We can. Okay, so the important thing here is that I would do basically the same command for doing a bar plot. The difference is that my data is structured with the information that I have. So I need this data in this format so I can do this. So it is the same function, the same commands here. I'm just using here colors so I can see the distinction between the 2 delivery methods. So I will fill based on that column. And I'm just plotting a geom bar. And now I'm using a scale fill function that already exists inside ggplot. So this is from the Brewer color palette. And I'm choosing the palette paired to show this information, okay? So that way we can have this bar plot. If we want to plot a scatter plot, this is data on geyser eruptions inside the Yellowstone National Park in the United States. So we have here the eruptions and the waiting time between them. And for plotting this is a basic scatter plot, 2 continuous variables. We'll do again ggplot, call the data, define what we are mapping, which columns we are mapping. This data already exists inside ggplot. ggplot has a lot of different data sets inside it, and they use it a lot in the examples. So we can just load the data and plot it by using ggplot, selecting the columns that we want, and to do a scatter plot, I will just use the function geom_point, okay? And again, I'm using my theme just to get the visualization that I want. Again, this is the same, like here, I'm defining data and mapping in my ggplot function, and my geom_point function is empty. I can do the opposite too. It will work. I just have to specify what is the mapping, what is the data, and I will get the same result.
So here, basically, if I put a plus, I can put everything outside in the order that I want, or I need to put...
Yes, yes. It will follow the order that you are specifying. So imagine that you want to add like dots and then lines, and it will add in the order that you are defining here.
Okay.
Sometimes you want to change to like, someone is in front of what you want, you can change that. Okay. And so here, there are other ways of changing colors, and because this is a categorical continuous variable, I can specify here the pattern that I want. Like I can use, if this was a categorical variable, it would work the same. But here I'm doing a logical test to color my graphic. So I want to easily see the eruptions that are higher than 3, that less higher than 3, and lower than 3. So if I specify here the color with a logical test, I will be able to change the colors here. Those are the default colors we can change. To change that, we would use a scale color manual or color whatever. When we are using the fill argument here, the functions are scale fill something. When we are using the color specification here, it would be scale color whatever. It's a lot of information. Every time that I'm doing a ggplot graphic, I'm on Google, like, change that on ggplot. It's impossible to remember everything. And for graphics especially, I always like to, like, it's always a good idea to have your scripts documented and like well stored somewhere. But I'm always consulting like other graphics that I did, and I start based on that and not based it on like an empty script, like from scratch. And it can be your own script or any script that you find on the web. There are tons of them. Here I'm specifying the color with the color function, and it is the same as fill, but as I'm not, see that if the aesthetic is linked to the data, so it has to do with those columns, it has to be inside the aesthetics function. If I'm specifying a color and that stands by itself, I can do that outside the aesthetics function here. So color, the color argument is outside, is in geom_point, is an argument of geom_point, not an argument of the aesthetics, okay? A way of doing histograms on ggplot, it will be the same. We always start with ggplot and then the jump function, in this case the jump histogram function. We can control the bins here. We can control how much the bar here is close to the y-axis. You can control basically anything, but this is the not digifold because I changed the bins here. I was getting a warning like this is not like a good bin division, and I changed it and it got better. So it talks to you, it helps you to build a graphic. And I'm just adding the theme. We can change everything, and the way we change the scales in the graphics is by using the scale functions. There are tons of that. They're like scales. I'm using here, for instance, scale y continuous, and I want to do a transformation in my variable by using log 10. I could do that on my data. I could set that my column now is the log of something, but if I don't want to change the data, I just want to change the visualization, I should do it this way. And there's also like, this is a generic function, and we can specify like different ways of scaling this graphic. But there is a function like scale y log or something like that we could like directly change to log without doing this. In my x-axis, I'm changing the breaks. So I'm defining that the breaks are 3, 5, and 6. And that's what I'm seeing here, 3, 5, and 6. Okay. So this is how we change the scales. And in ggplot, I really like this visualization. This is really good for exploratory data analysis as well. We want to see like how a variable varies based on whatever factor. This is MPG data set. This is fuel, data price, and consumption for different car brands, models. I know nothing about cars, but this is here. So we have like here different like minivan, pickup, like, okay, I can relate to that. And we have the different like variables here. So I could plot those variables. If I plot this without the facet rep, I would see all of them together. When I'm doing, I want to do a facet, I can just use the facet rep function. And the notation here is this sign, and I want to create one facet per class. So I do this, okay? This is a way of doing that. There's another function. We have face rep and face grid. They change a little bit on how they show us the data. So here is the same data set, but now I want to make a grid using two variables, year and GRV, which are like basically 3 different categories here. And again, I can see my scatter plot separated by different variables. And I'll show you one option. I mean, there are tons of options of grabbing more than one graphic and putting it together. We saw in other classes using par function and mf row, defining how many rows and columns we want. We will use here the package patchwork, but there are tons of different options. There's ggrid, ggextra, a lot of different options. I'm doing this because I like the notation of the patchwork. You'll see that. But I'm using here a data of memos, sleep patterns. And I'm plotting here This is the variable that is specifying the diet of each mammal. So it's omnivores, insectivore, it is basically anything, insects, just plants, or just other animals. I'm doing here a box plot, and I'm using the geom box plot function for that. So ggplot my data, geom's box plot, I'm specifying what I have in my x-axis and in my y-axis, how I want to color this. Those are the default colors. I'm just adding my team. I'm assigning this to an object. When I'm doing panels, it's a good idea to assign the plot to objects. And then I'm calling the object, and so it will show me, it will pop up the graphic, okay? So this is my first graphic. I have a second graphic that I want to show. This is my bar plot. It is how many animals we have within each category. I'm doing a geom bar, so I'm ggplot. The first line is the same in both of them. I'm just changing how I want to plot and which variables. I'm adding my team, and I'm just checking the graphic here. And the final one is a scatter plot between body weight and the sleep total time here. And here, I want to change my x-axis scale, and I'm using that using scale x log 10. This is the same as the other command that we saw before, but there's a specific, it's something that we do a lot, so there's a specific function for that. And I can load the package patchwork, and I can just sum up all of them, and I will get this. This is very disappointing, right? But we can control how we want to show the graphics here. So here, I really like this notation because it's saying I want like one window with P1 and P2 graphics, and then in the bottom, I want the P3. And it will automatically make those two smaller and this one bigger, okay? And I need to add this plot layout so it gets prettier than without that. And there's this function here, plot annotation. So I can write like a title here. I can add the subgraphs labels. And I'm doing that with the tag levels, specifying that this should be letters. So I'm just saying tag letters A, and we'll put here A, B, and C. This is the title. I'm putting a title here. We don't need, like for publications, we usually don't use title in graphics, but for presentations it's something that it can be useful sometimes. I don't remember who asked me yesterday for a plot like this. You. Okay, so he said to me, oh, I want a 3D graphic. And I said, no, don't do that. But this is, we need this package, gregis. Here I'm using a data set of diamonds. It has a lot of like information about the diamonds. There are like different categories of the quality of it and the depth and other measures of the diamonds. Here, I'm plotting the depth. So this is a histogram. Imagine that I want to explore this data, okay, understand how the depth distribution is for each category. I could do like a huge plot window with all of those 1, 2, 3, 4, 5, 6, 7 histograms. It will be a huge graphic. So this package is super nice for that because we can compare different distributions in the same graphic like easily, and it doesn't occupy a lot of space. Space is limited too, so this is a really good visualization when we want to like compare different distributions from the same variable, obviously. We have a common x-axis here. That's why we can do that, okay? So the way of doing this is basically all those packages that are connected to ggplot, they follow the same grammar. So this, if we read this, this seems like a ggplot function, but it isn't. It is just following the same grammar. So all the packages that connect with ggplot are structured like that. Here are other resources. We don't have much time for like going through all of this, but they're like, we can find anything on web, right? But there are a lot of information. There are like theory about colors and how we should pick colors, and we really should be thinking about accessibility and colorblind safe palettes. There are like tools for that. Color Brewer is a tool. There's an R package for that. So here are like websites to understand more about colors and color combination. It should suggest like color palettes that works together. And it depends if you have like different categorical variables or continuous variables or divergent categories or like a sequential category. Like there are suggestions of how to choose a better color palette depending on the variable that you have. Those are good tools. This Color Brewer website is super nice. We use a lot, like, I have like a bird graphic here. I want to add like the silhouette of a little bird in my graphic so it gets prettier. And there are like tons of icons available. You can use that. Just cite the person that did the icon and you can use for free. And those are like R packages that we can use to, they're like color palettes that already exist inside like a package. This one is my favorite. Those are color palettes based on Wes Anderson's movies. He's a director with very nice movies. And to finish, like there's a whole world of like building graphics in a computer. And there are people who do art, like generative art with this. And I will show you, this happened, can I just change like the like me from the graphic? Okay, great, thank you. So this is Daniele Navarro. She's like the most amazing person in the art community. She has contributed a lot. She's a statistician. She works in psychology area. And she has a lot of material about teaching statistics in R. She also is one of the co-authors of ggplot package. And I mean, she has like a website with like, and she teaches you how to do basically anything in life, like build a website, do statistical analysis, do graphics, do whatever. There's a conference called Use R. It happens every year. It's a conference for R users from different levels and people from like all different areas from all corners of the world. Last year, we had the first art exhibition in a user conference. And this was part of the art exhibition. So it was completely remote, a remote conference. And this was a slideshow that was going on, slides and music. And we built a package for creating those art labels here. So here we have Daniele Navarro. We know that she's Australian. The piece here is called Fire and Ice. She did that in 2021. And here is like the equivalent of oil on canvas that we see when we go to a museum. This is the technique that she used to create this. So this is totally built inside R. Like she does not do anything like, oh, she just does something and then she opens like an image program and edits. No, it's totally done inside R. This other guy here, Antonio Sanchez, he's a mathematician, and his art is basically based on mathematical functions. This is totally sines, cosines, and polar coordinates. This is totally built on ggplot too. And like this is like 6 lines of code. There are code here on these slides that are bigger than this. So this is art actually, and this is super interesting. And those people are experts in data visualization, and they end up Thomas Lynn Peterson, and is another co-author of ggplot package. He's also an art artist. He was in the exhibit as well. But now, okay, let's do one graphic together. So we will run. This is a short script that we will run. Let me open. I will change here to my project. Oh, I was stalking all of you on GitHub and to check how all of you are. And I was really happy to see that most of you have a lot of commits, and you committed like all the scripts here. But I saw some things like R scripts in the root of the repository. So let's try to put all scripts inside the R folder. And in the R folder, we only should have R files. R Markdown files will be on the docs folder, okay? So let's do that. And some of you were like, I don't know if you haven't like just made git push, but some of you were like, I saw were stopped on the second script or something. But I was really happy to see that most of you are working really well with R and Git. So what I will do here, in the main package page of today, I have this link. It's the same link that I sent you on Slack. If this is not working, I will just copy this. I will save this, save as a markdown before pasting, because it will understand better the indentation of the markdown file. So I'll go to my docs page here. I will save here as graphics.rmd. I will save this. It will say that this is no longer R script. Yes, that's exactly what I want. And I will paste here. If I don't do this, it will like paste, it will add spaces here in the header and in other points of the code, and it won't render. We won't be able to knit the document. So we will now reproduce the graphic that we created in the last week in the scientific workflows class. So I will start. I can run the code from Markdown to my console just by hitting Control Enter. It is the same. So I'm doing library here. It already sent. Ooh. Okay, my community. So I'm reading the community data from Cestus that we already know. So here I have my com object. I can check that. This is a species site matrix. I need the abundance of the species, total abundance of species, summing all sites. I will do that by doing this, call sums of com1 minus the first column, because in the first column I have the sites. So I'm doing this. I will have this vector. We have the names of this vector are the species names. The values is the species abundance. I'm sorting this from the highest to the lowest value. I'll get here com_sum. This is the same. When we plot it in RBase, we use it directly, this vector. In ggplot, we need this in a tidy format. So each variable I need a data frame always. So I'm building a data frame, And here, I just want the rank of each species. So this is the first most abundant, the second, the third, and so on. So I have one column that is the species rank, and the other column that is the abundance for that species. And I'm creating this data frame. I'll show you here if I do view, com, gf. I'll have this. It is automatically putting the names of my vector as row names. This is harmless and useful in this case because I can know which species we are talking about. And I want to create my plot here. So every time we are plotting something for, let me do this. This is going beyond what I wanted. Every time we are plotting something that will be like not published, but it will be in a report or in a manuscript or something, we should be careful and, okay, I'm setting the variables here. I'm controlling the size of the dot. So I'm setting size 3 because I want it a bit bigger than the default. I'm defining here the X labels, so species rank and abundance. I want to change, by default, I will do that, just the default, using the default to show you, and then we can see the difference that it makes. If I do this without controlling any of this, I'm just starting with this graphic, I get this, okay? I don't want to put, like in my report, this graphic because it does not look good. I want to control like different things here. I want to change the background. I want to change the labels here. I want to change the visualization that we are seeing here is completely different from what will be written on disk. So every time we are writing a graphic, we should write the graphic, see how it is outside R, and then decide how we will control, okay? So here, but here it helps because like I already know some things that I want to control. I want to change the scale here because this scale is like 0, 50, and 100. I want this to be, add more breaks here. So I will do that. And the way I want my breaks, like if I do a histogram here, I would get a histogram of those values. Okay. I want to use the breaks from the histogram, okay? So if I use plot equals false, I will get a lot of information here. What I want is those breaks, okay? I could create a sequence from 0 to 140 by 20, but I'm just doing like this. So if I run this command here, I will get this sequence. It is the same thing as doing sequence from 0 to 140 by 20. I could do that. I'm using this so I don't have to do that by hand. So I'm writing a ggplot. I'm saying that it will be a scatterplot, and I want the species rank in the x-axis, the number of individuals in my y-axis. I want to control the size. This alpha pattern here, let's get back to the graphic command. If I do this, by default, the dots are black. Alpha here, if we use the alpha parameter, we will control the transparency of the color. So I could use, so if I do this, I'll get a gray color here. It's not gray because this is like transparent black, okay? I'm setting my breaks, so I'm changing the y-axis scale by using the scale y continuous, and I'm setting that the breaks is my n breaks vector. And I don't know if you remember, but in the, let me open this. So this is what we want to reproduce. We had the species names annotated in the text. I won't do that as well. The way we do that on ggplot is by using the annotate function. And I need to specify what is the type of the annotation that I want to make. I can make different things here. I want to do a text annotation. I have to say where I want to do this. So those are the coordinates for where the location where I want to put my text. And I want this to be italic. And I will use this italic. So this is a notation for the computer to understand that this will be italic and there will be a space here. And I need to add this parse equal true so it can actually parse this command to the output that we want. And I'm putting here size equals 2. The size here was huge, so it was like a huge text. I'm controlling that to be smaller. And I want the classic theme because I'm a classic person. So let's do this. And breaks, I forgot to do this. If I do this, I'm just assigning to an object called P all my graphic. I'm not seeing, like in my viewer, my plots window, I have nothing now. But if I want to see that, it is here, okay? So this may seem like this is a bit too small, so I'm using the transparency here because when I'm plotting this, the dots are overlapped, so it's easier to see how many we have if it is transparent. And so that's how we are seeing this, and we will export the graphic. When we were exporting, I will open the code as well to show you. So the class that we did that was the importing data class. So I will open here the script here. Here, it took me 2 lines to control my graph. So in ggplot, things like we need more lines to control things. Oh no, not only 2. I'm not being actually. Okay, I need basically 3 different lines of code here to control everything that I want. And I want to do this same figure. So I was using plot, sort. So here I could use the vector as in the output from the call sums operation. But in ggplot, I need a data frame in a tidy data format. And then I was annotating the graph using the text function. In ggplot, this is annotate and annotate. The idea is very similar. And for saving this, I was doing PNG and setting the resolution and the dimensions of my graphic. This creates an empty device. I'm adding all the commands to my device, and then I have to use this devof to tell R that my device ended there, okay? This way was how we were saving the figure. If we generate things in R, we can do this like export and save, but this way, every time we're saving an image, we have to click and point and so on. So we can control the width and the height here. We can control by doing this, blah, whatever. This is a good way of seeing how the output will be. But like doing this, like every time I have to do this, I have to know like I want 397,332. So it's easier to just annotate that on the script. So we will never use like this way of exporting the graphic. And when it is like this, I can just like source this script and it will run everything and save my figure. If I depend on saving in the beginning, I couldn't like automatize the process. So this is how we save on RBase. Here, it's a bit easier. So I have my P graphic, and I just want to save it. So I can use the there are different ways of doing this, but in ggplot we can use the save function. It will save the last device that we printed. So I will call here my P graphic. It is here. And I will save in my figs folder. I will call this species abundance ggplot. I want a good resolution. Ggfo is 300, but I'm putting here because this is important to make sure that it is in that resolution. I'm plotting here like in the format, the basic format for a paper with like columns. So this is 3.5 inches. I can change the units here, and I can specify in centimeters or pixels or whatever. I'm doing this because this is a completely squared graphic of 3.5 for 3.5. And I can save this. And now I have here my figs folder. I have my species abundance figure generated by ggplot. I have the two species. It is the same, but doing in a different way. Okay, so I'm running this, like running the commands in my console. I could totally, I don't know what I changed it here, but I will save this. I could just to run this, okay.
I have a question.
Okay.
For the, do you have no? Wait, 1, 2, 3. English. In this case, because on the other script layer we could use the option if there is no folder we can create. There is something similar that can we do for the ggSave if there's the folder fig doesn't exist. Then
oh yes, yes, that will. Here, I don't need to do that because we already have the figs folder. But independently, if we are using ggplot or rbase, or independent if we're saving a figure or a table, we can always use that gcreate function. And I'm not doing this. I could do this. Could add this to the script, because this would guarantee that I have that. So I can use if dir exists. If it not exists, my figs. The 2 dots here is because the working directory that this file is seeing is the directory where it is saved. So it is inside docs. So I have to go outside docs. So that's why we are using here the 2 dots. And then we add figs. And this is the dir that we want to create. So if this not exists, it is false. We could use dir create this same dir. If we are already copy pasting twice, so we could do this like out dir. This is even more elegant solution. So our output dir is fixed. So if out dir does not exist, I can create out dir. So I will run this. It won't be doing nothing. If I do this without the if, I would get a warning. So that's why we are doing this. And then I save it. Okay, I run this like line by line, but if I want, I can just neat this document. So if I hit here this button, it will render our markdown file, and it will generate the output here. So here I'm setting the the default, actually I'm not setting anything for that, is to show either the code and the output, okay? So it's showing me the code, it does nothing, so that's why it is not showing nothing here. Here, when I called my P object, my plot, it will show here. Again, this is different from what we are exporting, because when we are exporting, we are controlling the format of the graphic, and then we save the graphic. Okay, ooh, lost that. I added here, let me show you, we didn't have time in the other class to show you the structure of a markdown file.
Sara, I have a question.
Okay.
In the annotation that you put the names of the species, I saw that you like put yourself the coordinates there.
Yes.
Is there a way to like,
oh,
I want species X to, for the name of species X to appear, or like the top two to have names appearing?
We could use, like, you could annotate here, if there are examples of how we could do that, like, imagine that I have a scatterplot and I want to annotate in all dots, like the name of something, blah, like, or whatever, like, this is A, this is B, C, D, E. I could do that just by passing to the X and Y the columns with the data. So X here is the species rank, and the Y here is the N. So I could use the column names for the X and Y. I could add, like, I think in annotate we can control, like, do this but go a little bit to the left or right or anything, but we could use, like, I want to add like 0.2 so it gets a little bit like on the side of my dot. We could use that. Yeah, we could do that.
Like you just put the two highest values.
Yes.
Can I just put a rule, like I just want the names of the two highest values? Or just the ones called bulbous something?
Okay. Yeah, you could do that. Like, you could do that by, you could do a loop for that. You could select the only two highest values and then put a loop to annotate, like, the first two, base it like in an automatic number, because that number I'm basically guessing where I want to put, like I'm defining based on the coordinates. But there are like several ways of doing this in a more automatic way, and you could use like a logical test to select something and then annotate only the data that you subsetted.
Yeah, like you will be saying, I just want the labels for D and A. And I
Okay.
could do that with a loop, you said?
If you want to do like more than I'm saying a loop because you are saying like I want to annotate twice. Okay? So that's why, like, or you could just annotate like all of them. You could just pass a vector to the label and a vector to the X and the Y. You could do that as well. But if you want to annotate like different things that you need a loop, you could do a loop there and add things. You could add the vector of the label, the vector of the X and the Y's that you want.
Sorry, last question. But then I have to figure out the X and the Y myself. It doesn't do that automatically. Like I just want a point that says that regards to A to
the
appear.
automatic way, you should say like I want to annotate where my value is. So it can only know that. Like I want to annotate that thing. So I could annotate, let's do that. I could like, Jean, let me do, I'll open here like a different script just to not do that. But you could do like ggplot com df plus annotate text. And my X is SP, my Y is COMDF. And so if I do this, okay, geom. This is not annotate, this is geom text. And then I'll do this, just statics here. So what I'm doing here, I can use the function. Jump to the label. Yes. Label is missing. So I want to write, the label can be the row names of COMDF, for instance. So here is a way, like I could do my geom point. And if I'm doing this, it will be like better to specify the aesthetics here because it's a common aesthetics for the graphics that I want to do. I want to add points, and then here I want to add my labels. I don't need this anymore, so I can reduce here. If I do this, ggplot, there's something missing. Oh, there's parentheses missing here. Oh. Stacks are the same of the, I have two AS here. Okay. So now I have like dots and my labels here. They are overlapping, so this is not a good idea. I could just like add probably, I don't know, 0.2 or something. Oh, no, not here. Probably the best way of doing this would be adding like COMDF x2. I will get x COMDF SP plus 0.2. Oh, it's missing an M here. So COMDF, now the column that now I need to specify my new X here, X2, Y, N, and if I do this is a little bit, it is not, let me try it like this, this will be, yeah, it is changing, not really much better, but I could do the same to the Y, that's why this is still overlapping. Let me add Y2, Y, it's not Y, this is N, Y2. It is still not really well, but yeah, we could control that some. It's still not.
They don't all go together, like they stay. I don't know how to answer. Because you are adding the 0.5 to all surveys.
Yes. Because here, like, we have this. If I add 0.5 to this, I will have this vector. So I'm setting that my X now is this. So all of them are 0.5 over there. One is two, I don't know, 5 maybe. Okay, this is a bit better now. But yeah, we can control that. Oh.
She's only missing
I think that if Sara uses a jitter function, the data won't be overlapping anymore.
Oh, but the jitter function works for inside a particular data. So if we have data that is overlapping, like we have 2 points, a lot of points overlapping, we can use the jitter argument to spread that so it won't overlap, but it won't work in this case where we are like working with different commands to add the data. But there's more that I want to talk here. Okay, let's go back to the markdown file that we just outputted here. Okay, so this is our output. Oh, let's go back to the R markdown structure. So in the markdown, we always have this header, and here I have Oh, can you hear me? Okay. Oh, let's see if it lasts for the last 8 minutes that we have. Okay. Okay. Maybe. Okay. So the structure of an R markdown file is that we always have this header, and we specify here the title, the date, the output that we want. This is not July 7th. We are like late. I can use here an R command as well to do this. This is something that we do. We can do like inside R markdown, we can have a chunk of R code together with text. We also can have, it's not the title that I want to change. It's only this. We can also have inline code, and the way to specify inline code is by doing like one, this accent, symbol here, so R, and we can use the function sysdate. It will tell if I ask here, what is my system date? Today is the 14th. If I use this, the thing is that if I need this document in another day, it will change the date here, but I can do that to say that we are doing this today. So we have here like text. We set heading using a hashtag, and if I want a sub header or a sub item here, I could use like this. So this, if I test this, if I run this, I will have here like loading, and this is like a slower level than the first. This is how we can set sections here. Actually, this is too big, so I will change this to in the rest of the code. And so I just have here like heading and code, heading and code, and heading and code. And inside, I'm just naming this chunk of code as setup here. This is just the name of this chunk of code. I have here, if I check here the outline, this is, I can check this, I can navigate into this. Okay, I have here one named chunk of code with my setup. I'm reading the data, I'm preparing the data for plotting. Basically, this is what I'm doing here. I'm creating the graphic, and I'm naming this as plot create. I wanted first to show the figure here, but I not showing the figure, this is outdated. So this is just the plot create. And here, this is what I want to show you, because we can specify, like people who can't see, they can still program in R, and they can still like read documents on the internet. And in order for that to happen, they use screen readers. And screen readers are tools that like extract the text from a particular file, and they cannot see a figure. So a way of describing, it's always nice to describe a graphic. Like in a presentation, you can do that. Like in the conference user last year, there was the recommendation for everyone presenting to add alternative text to the figure. You will see a lot of that on Instagram and Twitter. It's becoming more common for people to add the alternative text. So people using screen readers can know what is going on in the graphic. And sometimes we see people doing like, oh, this is a species rank curve, dot, blah. This is not enough. When we are describing what is happening in a figure, we should describe actually like the pattern that we are seeing. So this is a species rank abundance curve. Someone asked me the other day what this means, but let me just plot again. In the x-axis, we have the species ranked from, I think that other one is better too. Here we have the species ranked from the most abundant to the least abundant here. So this is just the position of the species in the rank, the position of the species in the table that we built, and this is the abundance. This serves so we can like see the pattern. It is a common pattern to have this J format. We have most of species are rare. They have like just a few individuals, and only a few species are abundant. And that is what we should describe here in the alternative text, the pattern that we are observing in the data. So it's a species rank abundance curve. On x-axis, species are ranked from the most abundant to the least abundant. Y-axis is the number of individuals of each species. The curve has a long tail to lots of rare species and only 2 species that are very abundant. I'm saying their names and how many individuals they have. So this should enough to substitute this figure. That's how we should think about alt text. And this is a recent change in R Markdown, and adding this alt text option in the chunk code here. And the way it appears here is that like people using a screen reader would be able to see, but if you click, pass your mouse, scroll your mouse in front of the figure, we would see this. We can do that in publications as well, like +1. We can do alt text, like there. I don't know if all of the journals are using that, but things are changing and people are adopting this alt text option more. In the art exhibition that I show you, the 2 pieces, we had alt text for all the art, and like there were people using screen readers, and they were super excited that they were able to see, to like get an idea of what we were seeing. So this is a good, very good tool to increase accessibility. And that's pretty much it. So graphics is a whole world, and there are a lot of tools and functions and commands. If you want to explore more, I highly recommend the R cookbook that is listed in the beginning. Oh no, let's finish. No, I'm forgetting to commit. Okay, so we added here today, I have 2 files that are not tracked yet, the docs and my figure. I will add both of them. I added in my git ignore this line to avoid adding all HTML files. So that's why I'm not seeing here in my window, or if I do a git status here, it won't show that this file was created. So I have git status is showing me only those two files. I can do this git add dot everything. It will add everything. If I ask again, what is my status? I have two files that were added. I'm up to date with my origin. I have those two new files. I will do my commit. So I'm adding RMD to replicate the SAD is the short for species abundance distributions, which is the type of graphic that we are generating. So I'm adding RMD to replicate the site's graphic using ggplot2. So, or I can just say like adding the RMD is already there. It's like obvious. So I could do this, just like replicating a site's graphic using ggplot2. I will commit and then I will push. And I can open my GitHub and check that if I actually succeeded on doing this. I want to see my repositories. So, where am I? Find a repository. Oh, here. So, in my docs, I'm replicating the SADS graphic using ggplot2. My commit is here. I have my README here. I really like it that some of you actually added a new line on your README. Not everyone did that, but I really enjoyed seeing your comments, very sincere comments. You all should have this structure, R, data, docs. Inside R, we should have the 4 scripts. Inside docs, we should have the 2 markdown files. Any other structure different from that, you can move your file to the proper folder and commit that, okay? So we all should have this structure here. And that's it for today. So next week, so today we ended our introductory module. So if we check here, we went through Introduction to R, Git, scientific workflows, data manipulation, exploratory data analysis, graphics with R. We did all of that. So you are more experienced users than you were when you started the course. Now, next week, we will start the statistical modeling module, and I will finish with you implementing, won't be implementing stochastic dynamics because you didn't have this class yet, but I will leave a tutorial for that. But we will implement logical Volterra dynamics inside R. It will be interesting. And oh, I want to ask you to do something for next week, okay? We have our document on Slack that no one really cares for that. But here, you could edit. Oh, you can edit. That's why you. Why you haven't told me that? Okay, but you can edit, right? Okay. Okay. So you can edit. I thought that this was closed for addition, and that would explain, but there's no explanation. But I will add here another section. This is plain Markdown. It's the same, like our Markdown is Markdown with our code. This is plain Markdown. I'll add here a session. I want this to be second heading, packages, or that I want you to think about what is your interest. It can be anything. It can be, I want to learn about like, I don't know, give an example, someone, you. What is like an area that you're interested in biology, ecology?
Oh, biology, ecology?
Yeah. Or anything else, anything. It can be like there's our package that connects with Spotify, for instance. You can be interested in that, I don't know. But I want you to think, you can say.
I can say?
Yeah, anything.
I work with mathematical models and I use a package named POMP that is like partial observed Markov processes. I don't know if we can work on that.
Okay.
Or maybe I like statistics, so it's also
Great.
a good idea.
So I want you to list like what packages you would use for a data analysis. So think about the theme that you work with or that you are interested in and list the package. We want to do this because we want to show you how we will do. Like we are experienced users when we are able to start something from scratch without knowing, like previously, just by finding the package documentation and following the, sometimes there's a vignette, sometimes there's only the documentation of the functions, but we should be able to grab any package and use it, okay? So I want you to list what you are interested in. We will pick, I won't promise that we will pick all of them. If you have like similar interests, we will probably pick like the most common one. But list your name, package here. And we want that information from you so we can prepare like extra activities for you, okay? Yes, I'll be here from 4 to 5, okay? No, in first floor, in the room that is next to the library with the big tables. That's it, okay? So thank you for today.
He has a question.
Oh, no. Okay.